Hello, DEFCON Red Team Village. Thank you for having me here for this training session. I'm Jeff Foley, the project leader for OWASP Amass. And today I'd like to go through this with you starting from, I don't know, what I would call ground zero. Just if you've never used it before, we're going to cover all the details of where do you get it, how do you install it, and make best use of it. So with that, let's get started. So what I would recommend is if you've never been to our GitHub repo before, go to that and go to the latest release. And what I would recommend is get the pre-built binary for your preferred OS, because this is the easiest way to get started. Less to think about. Just get the binary and start using it. Before you, of course, jump right into it, I would say go back to at least the README. Take a quick look at things we've already made available to you for getting started, such as alternatives for using it, such as Docker, the installation guide, the tutorial. When you get a chance to read that, would be a good idea. And just in case you're thinking of becoming a little bit more involved in our community, here's some tips for that. I would definitely recommend, no matter what, join our Discord so that if you have questions, you can ask us directly. All right, so once you've downloaded the pre-built binary, you would end up with something like this directory here. Inside that directory, you'll have the binary called Amass, and there's some potentially useful files in here, such as under examples, I believe we have the word lists in here. So later on, when we talk about brute forcing, this could be of interest to you. For right now, I have put the binary right here, and if we check the version, we'll see that it is definitely the latest version. And so we have it now. We have it on our Linux system in this case. So where do we begin? What do we do with this? Well, if we ask the program, we'll see that it has some subcommands. So I probably will not be going over all these today during this training session, but most people are quite familiar with the enum subcommand. We will probably take a look at the Intel subcommand, and I imagine we'll definitely be talking at least about the DB subcommand, maybe tracking today. But each of these subcommands has its own help information, and it has its own very different use. All right. So if we keep going with that, enum is what most people want to do with this program. So if we take a look at the help for this, this is has a lot more to tell us. So we will not be using all of these options today. Instead, like I said, we're going to start off as if we don't know much about this. So what I would say is you have to provide, as it shows here, at least a domain name with this flag, the -D flag, to get this program to do, or this subcommand to do anything. So why don't we just start with that, the simplest way you can use this. So if I bring this back up, what we can do is we can do enum-d and something like OWASP.org. So what this is doing right now is it's going to attempt to enumerate the information assets that are exposed on the internet for OWASP.org. So we'll give this a second to show us. So right now what we're getting back is these are the names for these assets, and that's it, just the names. And you could say this is kind of the minimal information that Amass can share with you about what it's learning right now. So if you've never used this before, this could be similar to your own first experience where you don't know much about how to use this tool and you're just trying to get it to do something for you. Right here, what you're seeing is it's telling us the performance it's getting from DNS. The retries required is, you could say, a little bit of a gauge for how successful is it with these DNS resolvers that it's using and your network performance. This information comes up every minute to give you an idea of how fast is this going, essentially, and to give you an idea if you're having any trouble with using DNS. So I'm going to interrupt this right now because we don't really need to wait for it to continue or finish. Let it finish. I mean, when it finishes, what it will show us is we call this the summary information. So it will tell you how many names were discovered, the categories of the data sources where it obtained this information. This is the ASN number for the network that not the names, I suppose, but the IP addresses that those names map to. Those IPs were found within this network, or these two networks that are registered on this ASN. So as we can see, they're in Cloudflare, or at least behind Cloudflare, and it tells you that it finished, and it tells you that it saved this to a graph database. So what does this mean? So right now, you have some information saved from this enumeration. On Linux, that information is by default in this directory, .config/amass, where you can see you have 4 files waiting for you in here. You have a JSON file, a log file, a text file, and this indexes.bolt file. So the JSON and the text file are 2 different representations for the output from this program, or what was discovered. The log file shows you things that happened during the execution. It could be good, or it could be errors that took place. There's all different things that are saved to the log file. If we were to quickly look, hopefully quickly, at this one, there's probably not a whole lot that took place, other than it saying it didn't have API keys for some of the data sources. It tells you when it started querying. And like I said, we've got a couple either errors or just kind of status information about what took place. Pretty typical. I mean, some of these look like errors, but they're really more like attempts that perhaps didn't work. Maybe some of the data sources didn't respond, which are possibilities. Okay, so, but this database, this graph database that it told us about at the end, and exists in indexes.bolt. So this is pretty powerful. It means that if we use Amass and we use the db subcommand, we can ask it to show us the names for the, not just the enumeration we just did, but actually if we ask it this, it will show us all the names it's ever found for this domain that have been saved into this graph database. So that's kind of handy, that you can pull this up anytime you want later. And it kind of builds up over time as you keep enumerating the same thing, or like it'll create a collection of your findings. For instance, like if you did the same enumeration again, but you did it with brute forcing, you know, hopefully you'd find a couple more things, in which case they would be added to the list. But I would say this is still just basic usage, right? This is, you did one enumeration, it saved the results, and you've just pulled the results back out. If I change what I'm asking for here, and I say, well, I don't want the names, I want the summary information, you'll get that, just like we had it before. If you ask it to just show you what it knows, essentially, it'll just print all of it back out. Now there's additional information that was collected though when this enumeration took place that was not printed because we didn't ask for it on the command line, but you can ask for it here, and we can ask for it in our future enumerations. I'll show you that right now. So if we say we'd like the names, but we would also like to see the data sources that provided the names, or we learned the names from. Now we can see that over here in the blue. So we can see that, you know, some of this just came from DNS, some of it came from, you know, Alien Vault, DNS Dumpster. You know, there's various data sources. We can also ask for, I'll take the sources out for a moment. We can say, please show us the IP addresses for these names. It's a little crazy for these names. We have a lot of IP addresses, but we can see that now. So it isn't unusual that when you run these commands, you'd probably have both of those things showing. So you can see the source, the name, and the IP addresses. So perhaps that's a lot right there. Maybe not. What I would say is, all these systems are, as you can imagine, these are all publicly reachable. So these are exposed on the internet, and this organization probably has more than just OWASP.org, for instance. So how do we find out more about OWASP, right? So if we use the Intel subcommand, there's some things we can do. Again, this is has a lot of options, but we're just going to use a few of them for right now. So it shows you up here, just like with the enum subcommand. So how do you use this? So for right now, I'm going to show you how to use it with the whois, or it's more like reverse whois information. There's some pretty neat things you can do with this using network information as the input. It's not going to be very relevant for what we're going to do today, but it's quite powerful. I would encourage you to take a look at it sometime. What we will do is we're going to use whois with the domain we're aware of, and we'll make it active so that we can attempt to get more information about our target. So it will be Amass Intel active whois OWASP.org. So what this is going to give us is it's going to try to find more domain names that seem to be related or associated with OWASP.org. Now, I'll tell you, there's no guarantee that they are. So you'll have to either decide to trust this, or you'll have to investigate these yourself and validate that they're definitely related to OWASP, or maybe just look through them and be picky about which ones seem related or something like that. But you can see that many of them look related here. For instance, let's see. Actually, the ones above looked a little bit more convincing. It looks like we're losing it. Maybe it's because it's continuing to look for more. Here, this is what I'll do. We'll take the active part out for right now. So some of these, like AppSec Latin America, AppSec DC, AppSec USA, these all, to me, look like they probably are quite related to OWASP. So we could take more than one of these and make this the new information that we do our enumeration with. So if we go back, so this is what we used before. Let's try this again. This time we will add the source and IP information, and here we will just throw a couple of these other ones in with it. So we have appsecusa.com, we have appsecdc.org, let's see, appseclatinamerica.com. Let's see if we can, we don't need every one of these, but about OWASP Lusa.com. We'll try these. And we'll run it again. So right now it says it's querying those data sources. Didn't take very long for it to start finding things. We can see we're discovering some things from certificates. Let's see, more certificates. We have some web archive discoveries, Alien Vault, Threat Crowd, Virus Total, DNS Dumpster. And we can see at least one of these. Oh, so see, we have new queries going out for the new names. So here's AppSec DC. www.appsecdc.org. AppSecLatinAmerica.com. So when it's querying these, if it already found some of the names, it won't, print them again or show them again. It may say that it will say that it's querying for the other domains, but there's no, I guess, guarantee as to whether it will, like what order it will end up doing all these in. It will start looking for that specific thing at the point where it tells you, but it could easily find it earlier, especially if these are all related to each other or perhaps sharing networks. What I'm kind of curious about is once it's finished, how many new things it found, which I'll show you how you can see that, or how you can find out easily without having to go through all of it yourself. We just need to give it a moment to finish. So see here, you can tell already it definitely slowed down with how many queries it had each second, and then it slowed down again, and now you can see it completed. So you can see just from looking at the number of names, right? We did find a couple more names. We were able to utilize more data sources, and we definitely found things on more networks across Cloudflare, but everything still managed to be within Cloudflare. We just found hosts that were on more networks. So if I go back to our original, let's see here, request, where we were interested in OWASP.org, now we've run two enumerations, and we're probably wondering, or anyone that did this would probably be wondering, well, so what did it find this time that it didn't last time? So what it's telling us here, at least, is if we're only including OWASP.org, the answer is, well, there were no differences discovered. Which I would say it's great that we can get that information back, because, for instance, there's no point in digging into this deeper if the answer is, well, it didn't find anything new. But let's go back to this request. Now this could end up being interesting, because since we haven't run this two times, it could still end up telling us that nothing's different, or even that it doesn't have enough information to give us tracking on some of these, because we haven't run more than one enumeration on some of these domains. Okay, but it did actually do what I guess you could say we'd probably be hoping it would do, which is, so we said, okay, we want all these domains considered in our tracking. Show us what's different from previous enumerations. And it did. It said, well, this time we found appsec. Or appsecdc.org, appsecusa.com, and appseclatinamerica.com, along with the www labels for two of them. And there's the possibility that in addition to this status here of found, there could be ones that were removed, and there could be ones that were moved. So some of these could, for instance, be hosted in the cloud or something like that, where they have a very dynamic IP address. And if you run this a week later, some of these perhaps will say they're in a different place now than they were before. So that's a quick and dirty on how to use tracking. But I know that I and many other people find this very interesting or very useful. I mean, that it allows you to run these potentially very long enumerations, but instead of having to go through all this yourself or try to pick out the new, say, gems, this can just kind of do it for you. It can say, here's what's different from what you already knew before. So we built this because of just how much time that can save people. Also, for instance, I've worked with CISOs who they've said, look, I just need a way to know when do new things show up in our namespace on the internet. I just want to know that this is new, and therefore I could engage my staff to ask, why is this out there? Is it hardened, to our standards and things like that? Because they don't have the time to be, honestly, asking their staff for every little detail of what's going on, and they don't have time to be, say, looking through all the data themselves. They just need a way to quickly say what's changing out there, and therefore, and with that, they can ask the right questions, like during the meetings and what have you. So it can be definitely powerful for people on both sides, the blue and the red. Okay, so I would call this basic usage. Like even if you've never used this before, you can quickly start using these features. Now, people like Jason Haddix have noticed, so I'm going to scroll up a little bit. This came out of our second enumeration, where we took more names, right? So Jason has pointed out that, well, once you get some of these ASNs, which actually we obtained this ASN right from the first enumeration we did, there are things you can do with the Intel feature to try to reveal more names. Now, in the case of Cloudflare, though, this would not be, what I'm about to show you is not something you'd want to do with them, because you're probably not going to end up with the information you are hoping for. But let's say that this ASN and the description it came with revealed that this appeared to be an ASN that was specific to your target organization. Then what I'm about to show you could be a very good thing to do, because it could end up showing you more domain names that are being used in that network. So if we type in Amass Intel, and I'll quickly go back to the usage information here. So when we're not doing the reverse who is, you pretty much have these options here where you can use address or infrastructure type information to point Amass as to where to look. So in this case, we'll use the ASN number. And like I said, I'm not actually going to use this ASN number because it would just end up kind of backfiring and giving us way too much to look at and many of it would not belong to OWASP. But if we type in this case, we would want active, so it would actively probe this network. And so this command right here, again, assuming this was not Cloudflare, and that you had some inkling that it did belong to or was somewhat specific to the target organization, if you executed this, it would probably reveal some additional domain names that are being utilized within their network. And the primary way it would figure that out is, well, it's two ways pretty much. It's either reverse DNS or actively obtaining certificates and looking at the certificates, which can make it useful to also possibly give it additional ports to look at. So by default, it's just going to look at 443, but here you could list all the ports you think perhaps web servers could be located on or listening on, and that could be useful to get more out of this enumeration. But what's interesting about this, so when you get more domain names back, you can kind of go back to this, you can kind of see a cycle forming here, right, where you could then do the enumeration again with more names, and it would most likely result in more subdomain names being discovered for those domain names. And you keep building out your visibility on this organization. So I would say this is kind of like your horizontal investigation of the organization, where you're trying to find out, like, what are all the registered domain names, and you're kind of getting a feel of, are some of these domain names barely being used, or other ones being used heavily, and you're getting a better feeling for where do we want to look deeper or more vertically at this organization, because that's where the enum command comes in. So what I've done for today is I have a domain name of my own that I'm going to use for this demonstration, but I'm not actually going to share it with this audience. So instead, I'm going to not reveal it, but for the reason that I'm going to try not to actually show who this is, even though I've been given permission. And instead, we'll just try to see how much it finds for this target organization. Before we jump into that, though, I'd like to show the Amass configuration file. So, we've done some very simple use so far of Amass. Like I said, that you could download this program and start playing with it the way I have just now. But eventually, if you continue to use this, you're going to want to know more about the configuration file. So this link right here, I'm going to bring us to that file right now. So if we go back to the repo, we go to the examples directory. The example configuration file is right here. So there's a lot of things in here, but there's some that are probably going to be important to a lot of people. So one is I would say there's actually 3 different modes you can ask Amass to execute in. There's passive mode, which we haven't seen yet. There's active mode, which we've kind of used, especially with, we've used it so far with the Intel subcommand. And there's this, I guess you could say, unnamed mode. I just call it normal, where when you don't specify a mode, it executes in a way that's kind of in between passive and active, where it's still using DNS, which passive does not do, but it's not actually actively engaging any of the targets or assets that are discovered. It's just using DNS to help in the discovery process. But this configuration file allows you to either just leave these off and you can be in normal mode, or you can uncomment this and specify one or the other. You can also specify your output directory. So as it says here, this right here is the default that I showed everyone earlier. But there's nothing, you can point that to be anywhere you want. And it could potentially be different every time you run the command if you wanted. Or more useful, I would say, would be maybe it's different for each organization that you're working on. So that way, the database that it's building is only specific to the organization of interest, as opposed to all the organization's information going into one database. One thing to note about this is, at least for when you have a local database being built, you can't have more than one, you can't have Amass running more than once if it's sharing a database or it's working on the same database, which is pretty much determined by what output directory it's using. So if you want to run more than one of these at the same time, and you have a local database being used, you would need to give them different output directories. So you could either specify that on the command line or in your configuration file using this option. This max queries, I would say, you probably can just leave this alone. I don't think we'll be getting into it today, exactly how that works. But quickly, I can just say if you bring this number down, it slows down the DNS activity. If you bring it up, it brings the activity up. I would leave it alone, since Amass already does a pretty good job of estimating what it should be based on how many resolvers you're using. Network settings, we kind of covered this earlier. We saw this with the Intel subcommand. I mentioned how you can specify ports for when it needs ports for things like certificate grabbing and things like that. If it's useful to you, or if it's easier than specifying it on the command line, you can specify your domains inside this file. Personally, I don't find myself doing this very often. I would call it inconvenient compared to using like a text file and just providing that on the command line. Resolvers, same situation. You can specify them in here, but I like to do this on the command line with a separate text file. Blacklisting can also be done with a text file or on the command line. This can be useful, this disabling data sources. If you just know you're not going to use some of these data sources and it's just slowing you down to have them on, this is a pretty good place to put them, or put the list of ones you'd like disabled. Again, pretty much all these things can be done on the command line as well, but I do kind of like being able to do this in the config file. I will not be covering the use of Gremlin databases today, so I'm going to skip that part. Brute forcing, which we will be looking at in just a little bit. You can turn this on in here by making sure this section is not commented out, and say that you want it enabled. Recursive is on by default, so you do not actually have to turn this on if you don't want, but if you want to turn it off, obviously uncomment this and make this false. This if you have recursive brute forcing on, this is a very important setting right here. The default is 1. What this means is that in order for recursive brute forcing to be initiated, Amass needs to see one label off of the subdomain name before it will attempt to brute force that subdomain name. The point of this is so that you're not brute forcing every single name that's discovered, because you'll wait a very long time for that to complete. You can do that if you change this setting to 0. Like I said, I would not really recommend it unless you're certain that you want to be doing this. I like 1, but maybe for some organizations, perhaps it makes more sense to set it to 2 or 3. I kind of do like that you can specify your word lists that you want to use in here, because it's probably easier, especially if you have more than one of them, to list them in here than it is to deal with all this on the command line. Name alterations are on by default, regardless of whether you turn things on in here, but you perhaps would want to turn this on if you wanted to change some of these settings, or if you just wanted to be able to turn it off so that it doesn't do it when you use Amass. You could turn on the section and then say enabled equals false, and that way it would just turn it off every time you use it. But maybe you just want to turn this on so that you can have some of the alterations activated while some of them are deactivated, or similar to brute forcing, so that you could specify your word lists that are used for alterations. And then this is probably the place in the config file that most people are interested in. It's where you can specify your API keys for the various data sources. Another thing you can do here for each of these data sources, even if they don't have API keys, is set a time to live. And what that means is if you have a time to live for a data source, and what it means is time to live number of minutes. That's what this is here. So, for all of these, it's a number of days that's been specified for the time to live value. And what that will do is make it so that when it goes and gets the data from that data source for a given domain, it's going to save it in the graph database. And it will not go get that same information again from that data source until the time to live is up. So that way you could have a great time playing with Amass and trying different settings and all sorts of things to try to get more data, but you won't have to worry about like burning out your subscriptions for these data sources, because you'll know, well, it's not going to actually go ask for the data again until a week has gone by, or whatever amount of time suits you. But this is great, I think, because it means you can play with brute forcing, you can play with name alterations, try all sorts of things, and not have to be concerned about using up all your credits and things like that with these data sources. And just, you might think of it as just being respectful to these services. So you can specify time to live for any of these. As far as the API keys are concerned, or the other authentication information, if the options for the data source are already in this example file, you just have to uncomment it and provide the API key or provide the username and password in order to allow Amass to get access. So I just wanted to cover this quickly. It is pretty important if you want to get maximum value out of this tool. I'm going to use it, like I said, in a moment, so that I can actually, you could say, conceal what we are enumerating. But I want to be able to show you, for instance, like what happens when you use brute forcing and things like that. So with that, we'll be using Amass, enum, source, IP. We are going to activate brute forcing, and I'll specify a different. So if I just run it with brute turned on, there is a default name file, or sorry, word list file that it will use for the brute forcing attempts, but it's a small file. It has like 2,000 words in it, so it's probably not the one that you're going to want for your engagements or enumerations. So you'd probably want to pick a different file. So earlier I showed you how there are some word lists that come with this zip file that was downloaded. Under examples, word lists. Now, I don't think the default file that Amass uses is actually included in here. Some people have asked that question before. But for instance, for this demonstration, let's just go with, I'll just pick the one that has 5,000 instead or something like that. But that's how you would do that. You would say brute-w to specify a different word file, assuming, of course, you didn't do all this in your config already. And now I am going to specify a configuration file. Which has details of my target in this case. And then what I'm going to do is, there's a feature Amass has called demo. So what this is going to do is allow us to run this, but you'll see a lot of the information is like redacted, or it's not available. So you can't get the complete information about the target, but it will allow us to see just how much was discovered. Now, this is a small target. I picked it on purpose for this demonstration so that we're not sitting here for the rest of the time watching this happen. What I want you to see is, first of all, how do you use brute forcing, and just get an idea, I suppose, of what this is like when it's a bit busier. Oh, one more thing that I wanted to include in this. So I'm actually going to copy this and show you something else real quick. So if you were to run that command that I just had there, it's going to use the default DNS resolvers. Now, this comes up quite a bit in people's questions. The default resolvers are not the ones that your OS uses by default. They're these public DNS resolvers that are fairly high performance and also reliable, since there's many public DNS resolvers out there, and unfortunately many of them are not reliable and they return false positives and things like that. So there's a handful of them that are available in the Amass for you. But it's only, I want to say, like 6 or 8 of them. And if you want to get Amass to go a little faster for you, you're going to want more resolvers than that. So what I did is I brought some for the demonstration. So they're in this file here, and it's simply 25 resolvers that I managed to come up with, and they seem to work well for today. I have no idea really where these are, who they belong to, or anything like that. They're just publicly available. But I'm going to use them by putting our command back up here. Excuse me, and saying RF for resolver file, and then giving it the 25 resolvers. So what this will do is it will make it so that Amass will not use the default resolvers. It will set up the enumeration to use those resolvers instead, and it will also automatically try to speed things up to consider the fact that we're now using 25 resolvers and we're not using just 6 or something like that. All right, so now we are ready to begin. So we should see this looking fairly normal, like when we were doing this to OWASP. You know, we're going to see that it starts querying. Oh. Yeah, interesting. Okay, so anyway, we can see that brute forcing is showing up quite a bit in the activity. Also, when things slow down a little bit, we'll be able to, it probably won't take long to see that this is going quite a bit faster than our previous enumerations. So let's just give it, yeah, so, well, that actually isn't much faster yet than it was going, I think, with one of our OWASP enumerations. But when we give it a moment for the engine to really start collecting a lot of names to attempt, we'll see that this activity will go up. It will probably also cause the retry percentage to go up. I mean, that could totally depend on how reliable your connection is, say, to these DNS servers, but it also probably has a lot to do with if you start sending too much to these servers, they're just going to end up dropping a lot of the traffic, and you're going to have to resend it. The implementation that Amass has for DNS resolvers attempts to detect when that is happening and slow down the activity if the percentage starts to get too high. But it's really hard to predict exactly what will happen. But like I thought, or I was saying, so you know, we've gone up in speed quite a bit, and it's also caused us though to up our number of retries that we have to make on these queries. Now, since this is a pretty small target, really, well, I would say it's unlikely we would ever end up maximizing on the 25 resolvers because there's just simply not enough names really to get that to happen. So we went up a little bit more. Now we're at 4,000 queries a second, and actually our retries rate has gone down a little bit. But I mean, at 25 resolvers, you could probably easily find yourself at 10 or 12,000 requests a second. And I'm actually going to interrupt this. So yeah, you could find yourself holding a speed of anything from 10 to 12,000 queries a second easily. Really, I mean, it maybe even better than that. but probably not against something so small like this. So actually, what we just experienced, maybe this would be good to show everyone. So it might be a little hard to grasp given that so much of the information is missing. But what happened here is everything was going pretty well, and then we got this spike of activity. Quite a bit, actually. So here, at this point here, I would say we were still doing well, and then all of a sudden, all these crazy names started being, coming up as valid or verified names. But they all, were resolving to the same IP. When you see this, if you see this happen, this is a pretty good sign that what's taking place is these aren't really legitimate. You've probably hit a wild card and it wasn't detected properly, or it could be that you're using a DNS resolver that has now decided to start giving you false information and just started saying yes to everything you're sending it and trying to get you to go to a IP address that it wants you to go to. The reason this happened, since I happen to know that these resolvers have been working pretty well today, is this is probably because we're on 3.8.2, and this problem has been fixed because we were just working on it recently. So the release that's coming out soon will probably make it so this is even less likely to happen. But I think maybe it's good actually that it's happening in this demo, because sometimes people haven't been aware of, well, what does this mean? Or when I see this happen, what should I make of this? I would say it either means you're running into a problem with a wildcard detection issue, which would be a good reason to use blacklisting. If you could just say, well, if we know it tends to happen on this subdomain, then maybe we just want to avoid it. Or it could mean you need to get better resolvers or DNS resolvers. Okay. But as you could see, the kind of the point of this was we used brute forcing, and it definitely creates a lot more activity. I personally find myself pretty much always using brute forcing and name alterations. There's just, I would say, in my experience, there's always going to be part of the namespace that you're not going to get from certificates. You're not going to get it probably from like regular OSINT. You're just going to have to make additional attempts and get lucky, basically, until you actually start to know the target a little bit better, in which case you can tweak your brute forcing and your name alterations to, I guess you could say, make sure you're covering certain types of names by using masks that we support name masks or word masks. So I'm not going to dive into that right now, but I would say definitely check it out in the documentation. It's really quite easy to use. You can use it on the command line, or you can incorporate the masks in your word lists, and then Amass will expand the masks to cover all the possible names that match the mask. And it's probably not going to help you that much when you're not very familiar with the target. But once, assuming you're going to keep working on the same target, maybe it's a bug bounty program or something like that, or a customer that you're working with quite a bit, you're likely to get to know their name schemes schemas quite well, and I would say it would make sense to create the masks that will be sure you're attempting on those names. Okay, so the next thing you might want to consider would be if you're still just starting to work with this tool, you're just getting used to how do I learn more about the targets and start making better choices about my recon. What I like to do is look at the target. I like to get to know, well, what does this mean? Other than just a bunch of names, what does the infrastructure look like for this target? So another subcommand that's supported is the viz subcommand. And just like so much with this tool, there's many ways you can use this, but I'm going to keep it pretty simple today. And it's a pretty simple subcommand anyway. It's viz. You have to choose output formats that you're interested in, and there's some other typical options in here, like what domain are you interested in looking at? If you have a certain output directory that we're using, the dir flag is what's used. If you're using a configuration file, then you can still specify that here. Otherwise, a lot of these are just related to the output format for the data that's going to create. So, for instance, if I simply say Amass viz, and I say I want it in D3 format, and for now we'll just stick with OWASP.org. And I run that, it's just going to generate the output file for OWASP.org, but it will be located in the default output directory, since we didn't specify a different one. So if we look in there, it will be in here as Amass_D3. So if I open this back up, it's not going to let me. Nice. Let's see if this will work. Okay, good. Okay, so as you can see already, this isn't a very exciting target, which we already kind of saw earlier, because it just doesn't have a lot of names. It's not very large, and they've done a pretty good job of concealing it with Cloudflare, so it doesn't really have much structure to it, because it all appears to be going to one place. But there's still something to look at here. So when you look at these nodes in the graph, they all have tooltips. So we can see pretty quickly this big red one in the middle here. This is a domain. It's OWASP.org. It says that it was found, or the name at least was found using DNS Dumpster. These green ones are connected to the red. So this is a domain name. These are subdomain names. So we can see the various names that were discovered. Now, these orange ones are the IP addresses. So the reason this all looks so messy here is that many of these names, let's see here. So many of these subdomain names are just pointing to the same IP addresses. So they all end up just looking like one big cluster right here. There's a few records here that were found, these pointer records, where it's an IP address that then pointed back to a name. So these could be actually pretty interesting, given that they do not appear to be, let's see here, yeah, they are not the same here. Let's see. Right, they're not the same network. So that could be interesting. These could be useful IP addresses for maybe further investigating this network. So that's what these yellow ones are here, the pointer records. And they were discovered during reverse DNS. The pink ones are the net blocks. So these IP addresses are within these net blocks, or like CIDRs, and they all belong to this AS, which we saw earlier as Cloudflare. There's also a name server right here that was discovered. And as we can see from all this, and we also saw this earlier, there were quite a few CIDRs that were discovered during the enumerations. If we look this way to this piece of infrastructure over here, these are all MX records. So that's what these purple ones are. So you can see, I kind of look at this as typical Google mail right here, where all these are Google mail servers, and they all belong to google.com. So that's all this is. It's just a lot that was discovered in the process of investigating this organization's mail infrastructure. But this is interesting because a lot of this doesn't get revealed in the just typical output of Amass. If you want all this information, you either have to look in, currently at least, you have to either look in the JSON file, which would have all these records available to you, or you have to look at it visually like this. And in the future, we're going to have some ways that you can query the graph database to pull this information out. But right now, I'll admit your options are somewhat limited just because we haven't gotten around to all these new features to do all of this with the graph database. But I've always been very visual. I find looking at this very useful because, you know, like we just noticed a moment ago, some of these records could give you new information, things that perhaps if you included it in your future enumerations, you would find even more information about your target. All right, so I think we're doing pretty good on time because one thing I was hoping to cover here is our new scripting engine, which is a bit more complicated than some of the things we've covered so far. So at this point, I would say we've gone from basic use to a little bit more intermediate use, like for instance, making sure that you're comfortable using the configuration file. Some of the more interesting options for like how to control your brute forcing. We talked about the time to live on the data sources. But what if, for instance, you had other, say, other data sources or other tools maybe in your workflow or your recon workflow, and you wanted to pull that all into this, right? Like you didn't really want to have to execute all these things separately and then collect all the data afterwards and try to get it all, like say, normalized or in one place. You just kind of wished you could make all that happen easily. Well, Amass is making that easier by allowing you to wrap your own, say, they could be your own tools, they could be your own databases or data sources that maybe they're not publicly available. For instance, if you were doing this for a blue team, I realize this is Red Team Village, but if it was for a blue team, maybe you have like a asset inventory that you want to be able to access when you're doing these enumerations. Maybe your organization just has its own collection of information about these targets, and you'd like Amass to be able to utilize it. So I have an example of how you can do that I'm going to demonstrate to you today. So Amass makes this possible by using a Lua scripting engine, which it's really similar to the way Nmap handles its scripting with NSE scripts. It also uses Lua. We have ADS scripts, which is Amass data sources. So what I've done is I've put together this test directory, which it's going to be our output directory. And I've put two things into the directory. So I mentioned earlier how you can put your config.ini file into this directory, and it will, well, actually, maybe I didn't mention this, but it's definitely worth mentioning that if you build a config.ini file and you know you're going to keep using the same output directory, you can actually just drop it in to the directory. And when Amass finds it there, it will just automatically use it. So you don't have to keep specifying it on the command line. But there's another type of file that you can specify in your output directory, and if Amass finds it there, it will use it, which are these ADS scripts. So if you create a scripts directory underneath the output directory, like this one, and it finds ADS files in there, or anywhere below the scripts directory. So you could have like a hierarchy in here of different scripts and different categories. Amass will go find all of them that are underneath the output directory script, the scripts directory. That's all it has to be. It's just this that needs to be there. But when it finds these other files, it will use them just like the ones that are available by default with Amass. So I created one in here that you could say could be like representative of one that you might decide to make. And we're going to take a look at it real quick. So these scripts can be either extremely simple, or they can be quite complicated if that's what it takes in order to utilize your data source. But there's some things that are common across all of them. So they all have to have a name specified, and they all have to have a type. You have to have those two things in your script, or when Amass finds it and tries to load it, if these aren't in there, it's just going to say, well, this isn't a valid script, and then it'll let it go or drop it. So you have to put those in there, and the name has to be unique across all the scripts that are being loaded. The type is a category. It doesn't need to be unique. You can find all the various types in the script documentation in our repo, which I'll show you is quite easy to find. So if we're in the README file here, you can scroll down to documentation and then go to the Amass scripting engine manual. There's a handful of information in here, but see, here's the type field, and it tells you here are the types that are currently being used. There's quite a bit of information in here, so we're not going to go over all of it right now, but if you're really looking to build these scripts, I would say definitely read this. For instance, it talks about these various callbacks, which we're going to see this vertical one in just a moment. It tells you how to write these and what data comes through to them. So yeah, definitely take a look at this. But if we go back to our example for Asset Finder, this has a vertical callback. So that means when it's doing vertical name correlation and it's trying to find new subdomain names, it's going to, when this script is loaded, it will call that callback to try to request more names for this domain name. So in this case, though, since we're not going out to like a website or something like that, we're actually going to tell it a command to run, and run the command, grab the data, get the lines of output, and then we're going to send them along to Amass to be considered as candidates for verification, or to go into the Amass engine for the enumeration process. So it's not, there's kind of a lot going on here, but actually this is a very simple script that just kind of wraps this binary, which is located inside the output directory. So if we look in our output directory under bin, you'll see that I've just put Asset Finder inside there. So that's where the binary is located. So if we try this out, by just running, a pretty simple enumeration. Let's see, for right now, we'll just do OWASP again. Well, what I could do, I guess you could say, to try to encourage Asset Finder to be used. Actually, what we'll do, I'll show you two things at the same time. What I'll do is I'll actually make it so this is going to be a passive. We're going to run this in passive mode, and I'll actually tell it that I want to include Asset Finder, and I'll just don't worry about what RADB means at the moment. In the upcoming releases, it won't actually be necessary anyway. But what this really says is we're going to do the enumeration, we're going to show the sources, we're going to go in passive mode, which means we're only going to just collect the findings and print them out. And we're only going to use Asset Finder. Yeah, which means we don't need this since we're in passive mode. So we should be able to use this right now, and if you think about it, all this means is we're really doing nothing here other than using Asset Finder. It's like we're using Amass and we've just wrapped the use of Asset Finder. So if we do that, and we're in passive mode, so we're not going to end up verifying the findings. So there could be names discovered right now that we don't actually know if they're legitimate. Oh, forgive me. No, but this is actually another good example. So the mistake I made here is I forgot to mention that we're using that one output directory. So it tried using the default output directory, and it did not find the Asset Finder script, and then therefore it had no data sources to use. So it said, oh, well, no names were discovered. But if I tell it the way I should have, that we're going to use that test directory as our output directory, now it will find the script properly, and it will know what Asset Finder is, and it will end up using it. So as we can see, Asset Finder was executed, and it found these names. And like I said, since nothing else is being done here, it's purely passive mode. We have no like DNS resolution going on, so we don't know the IP addresses for these. We don't know the network that they're on. So there's nothing more to do other than print the names out and terminate. So that's exactly what it does. If we didn't run it in passive mode, you could say Asset Finder would simply contribute to the rest of the process. It would feed the names in, and all those other activities would continue to take place. And what you'd likely see is that some of these things would be discovered by Asset Finder, some would be discovered by other things like just DNS data that we get from DNS and what have you. It would also depend on whether we still said we just want Asset Finder to find these things, or whether we want other data sources to participate. For instance, we could take out these constraints, right? And we could just put IP back in here and run it again. See what happens. What we're likely to see is that some of these are probably going to be found by Asset Finder. Some will be found by the other data sources, but we'll get all the data back. And it will be verified data, since the engine is taking all the steps to, do the DNS resolution, to do the reverse DNS, to look for all the various records it can find, all the things that are happening behind the scenes. But we can see right here, so Asset Finder found this name here, it found that name, found this name. So it's definitely contributed to the enumeration. We got another one right here. So imagine though how you could have lots of scripts like this, and maybe lots of binaries that are all contributing to your recon, but it could all be coming back to one place where you could expect that all these different tools and all these different data sources could be providing potential names or to be investigated, but you'd have one system that is verifying all the names, making sure that we're trying to find as much as we can from these names and the IP addresses that come with them and things like that. And when it's all done, it's bringing it all back into one one database, one storage location. Or if it works better for you, just one file. For instance, well, before I move along, notice we ended up with the same number of names so we had Asset Finder help us, but when we verified the names using DNS, we still ended up with the same number of currently valid names. But we had another data source to try to help us. If we look in our output directory, we have some additional files. So we have our graph database now, but we also have like this JSON file where we could use that as our, say, one piece of output now that we could utilize in other parts of our pipeline or whatever activity it is that this recon is supporting. Maybe that JSON is the easiest to use piece of output. But at least now you have one file that has all the data in it. So, like I said, that script was really simple. If we go back to the documentation about scripting, there's other types of callbacks that you can set your script up to use. For instance, this is a pretty powerful one. For every name that was resolved using DNS, you can have your script find out about it. Maybe your data source would allow you to take these new names that are found and for each one of them, perhaps ask more questions and try to find out more about our target organization. The example here just says, oh, well, maybe crawl the web pages looking for more names. For every what I call a proper subdomain name, meaning that it was a subdomain name and it had a label hanging off of it, meaning it's actually this is actually a subdomain. Those get reported through this callback, and it tells you how many times that subdomain name has been seen, or how many times a label has been hanging off of it. So maybe you set your script up to say, well, when the number of times equals 1, meaning we've never seen this one before, and this is the first time it's shown up, again, maybe you crawl it, or maybe you have something else interesting you could do, like your own type of brute forcing, perhaps, on the subdomain name. When new addresses are discovered, your script could find out about those, or when new addresses have been discovered and we're looking to find out more about our target organization from the address. When we want to know more about infrastructure or AS information, your script can participate in that part of the enumeration as well. So those are the callbacks. There's some other interesting functions in here that allow you to like obtain information about the enumeration's configuration, getting access to the word lists, writing logs out, all sorts of things can be done from your script. You can check if things are in scope of the enumeration. There's some basic, like regular expression matching functions that I've exported or made available. You can request web, HTTP client requests from the script. You can scrape web pages, crawl web pages, and then a lot of these functions here are for when you find things in your script, contributing it back to the engine. So you can tell it about new names, associated domain names, new addresses that are relevant to the target organization, new ASN information, and that's about it for now. Although we're definitely expanding this part of the tool. There's likely to be support for new things you can ask to do from within the scripting engine, and probably some additional like for instance, one callback that is not available yet, but probably will be in the future is when we're looking for more who is information. We could have scripts contribute to that as well. So definitely pretty powerful, I think, for the future of this tool. If we're looking for people to come to us with ideas about this, if people have trouble with it, we're definitely looking to improve it quickly. There's a lot of information up here about where you can learn more about exactly what these like libraries are that we're using to support Lua. Maybe where you can learn more about the language itself if you've never used it before, what have you. So that's pretty much what I was looking to cover in this training session. There are some other things, though, that I feel like a lot of users, when they're trying to communicate with this project and they want to like get answers to their questions quickly, or maybe even like contribute, whether that's in the form of bringing, say, problems they're having to our attention because they think maybe it could be a bug or something like that, or maybe they want to contribute code or improvements. Some of that information about, well, how do you go about doing that is on in our repo, but I think it wouldn't hurt to mention it here so that people could say get right on the correct track. So if you don't have like a problem or a feature request for this tool, I would say you probably don't want to bring your concern to the GitHub issues, because we're really just using that for ideally either you actually have an issue and you're sure about it, like you found a crash or an error or something that's not working right, and you've gone through the trouble of making sure that it's definitely the tool and not, say, the way you're using it. If you're sure about this, then certainly share it with us in the issues. But the issues are really being used primarily as a place to keep track of all the feature requests. So as we're doing development, we can kind of check the boxes or keep things organized there. We're using the Discord server as our place to come and talk, throw ideas around, share possible problems or troubleshoot problems before we say make it more final in the GitHub repo. So if you're on our repo again here in the README, right here at the top, this right here will get you to our Discord server. It's open to anybody, so please join that and see, share your concerns there first, I would say. Also, if you're just having trouble running it, I would really say try using it in Docker. It takes a lot of the installation issues off your hands. It's easy to run things, I think, in Docker. And this link right here will bring you to our Docker Hub official images. If you would like to become a contributor, like you've decided I really love Go and I really want to contribute to the Amass project, or you just you really love testing and you would like to help us make sure that we're staying on top of Amass working properly, and our feature development isn't, say, bringing new problems with the features, and you would like to help us test that, we could always use contributors to do that as well. If you're interested in helping us with our documentation, we're always being told we could improve that, and I believe it, or I'm definitely in agreement. So there's a little bit of information down here about contributing. I would really just say, which I think it says right here, please come to the Discord server, find me, send me a direct message and just say, I'd like to help contribute to this project. And we can quickly get you introduced to everybody else and start talking about, so what are we working on and how can you help? There's so much that's been done on this project, not by me, but by the other contributors and just the community that's using it and the people that have come to us and shared both what they'd like to see from it, where they think improvements could be made, and just people sharing their ideas. And we're definitely interested in hearing about all that, regardless of exactly how much time you have to contribute, whether it's just being on the Discord server and sharing your thoughts here and there, or whether it's you got a couple hours a week that you think you could throw at this, or maybe you're more serious than that. Either way, just let us know and we'll talk about it. Also, if people are writing about this or making, say, video content and things like that, if you would like to make sure we are recognizing your work, please, again, come to the Discord server, let me know about it, and we'll make sure that your work is being recognized by OWASP. So, I try to stay on top of what people have put, the video content and the blog posts and things that people have written about this and discussed. And I, like I said, I try to stay on top of it, but I doubt I have found every single thing out there. So please feel free to come to me and just let me know that you did you worked on something and you'd like it included. Yeah, so what I'm hoping happens now is when this video is being shown, I'll be on the Discord. Hopefully we can use the remaining, say, 15 minutes to answer questions. I'll probably be answering the questions the whole time, I imagine, but perhaps people have other questions that would require me to, I don't know, show them other things within the Discord channel, and we could use the remaining time to do that. I always try to leave, say, 10 or 15 minutes at the end of these to just focus on answering people's questions. I guess maybe a few more things before I wrap it up. One being, sometimes I have people say to me, well, how do I know what data sources are even available from this tool? And in case you don't find the option for this, I would say, let's just show you right now and you can see it. So this will show you all of them. So that should include, let's see if I'm right here. If we're specifying a different directory, let's see if it included, well, it didn't. I was going to say it should include Asset Finder, but I have a feeling in future release, the next release, I have a feeling it will. But either way, it prints out the list of data sources. Also, in the upcoming release, I think this information has not only the name of the data source, but I think it's now also showing you the category that it belongs to. And you can also, in your includes and excludes, you can not only specify each individual, say, data source that you want to use, but you could just say, well, I want all the ones that use APIs, or I want all the ones that use certificates. And you can just kind of make like a short list that expands out to all the individual data sources that fall within those categories. So there was that. I thought I had something else on my mind, but yeah, let's fall back to like I said, we'll take questions now. Thanks again, DEFCON Red Team Village, for inviting me to do this. It's a pleasure, and I'm always trying to help people understand how to make best use of this. Like I feel like I've foot-stomped pretty well already. If anyone has any questions about this, don't just try to speak with me right now, but definitely come to our Discord server, and we can talk pretty much any time about how to make best use of this. If anyone also has ideas for new data sources, like I said, either write your own scripts if you want to access the data sources, or come to us and speak with us about it. If you want to get examples other than my example I just showed you here for, well, where are all these scripts written? Like, what do these scripts need to look like in order to, say, access a typical data source where you're scraping the data or where you're accessing a API? You can find them under resources, scripts, and then they're broken out into the various categories I was talking about. So for instance, under certificates, if you look at like census, so this one shows you how to, it's somewhat complicated in that census can be accessed with or without an API key. It's just that you get far more information from it if you have the API key. So it will run it in this more basic mode without the API key, which happens actually by using the built-in scrape command function, or by accessing the or doing the API query. But like this is a pretty good example of, you know, a rather complete implementation where, you know, it does everything, including making sure we are using the responses within the time to live window, you know, parsing the JSON, making the HTTP requests, saving the or caching the responses, all the different things that typically go into accessing a API data source. You know, honoring the rate limits, making sure that the engine knows that your script is actively working on something so that it keeps everything alive and waiting for you, basically. So there's lots of these scripts available in this resources directory where you could learn how to write one in case you want to make one yourself. Some of them are extremely simple. Like if you go to scrape, I mean, pretty much all of these are very easy because a lot of them, all they do is they have a name and a type, a rate limit, and they just say, okay, so build the URL for the target domain and scrape it. You know, it's there's not much to it. So that could be the extent of the work you have to do if all you're looking to do is scrape a web page and try to get domain, you know, subdomain names that are within scope. But if you are doing something more complicated, like some of these, I mean, accessing APIs aren't particularly complicated, but I don't know, let's just pick one of these. Again, what's more complicated about this isn't really going and accessing the web content. It's some of the stuff that's built around it. If you're going to write your script so that it takes full advantage of all the features that Amass has for saving the findings and things like that. But once you look at these examples and you get to know, like you kind of see the patterns of what's going on in here, it should be really pretty easy for you to write one of your own. Probably even if you've never used Lua before, after you've seen a handful of these, you should just be able to get an idea for how this works and write your own. Here's the one for chaos. Again, not really that difficult. All right, I think that's all I have on my mind. Thanks again, and we'll talk more in the Discord channel.